Okay, so to explore our transformation rules, I want to use Desmos. You can follow along with me by going to desmos.com. We're going to start by clicking on Start Graphing. This is a really cool website that allows you to graph things fairly simply. So we're going to go through the transformation rules that are listed on your Canvas page. We're going to do those exact ones and talk about what happens when we move the graphs a certain direction. We're going to start off by graphing x squared. So we're just going to do y equals x. And the way you do a squared is you're going to do shift 6 and do a 2. So that's our parent function, our x squared parent function. So the next thing I want to graph is I want to see what happens when we do x plus 3 and then square that. So y equals x plus 3. I'm going to end my parentheses. Again, I'm going to do shift 6. That's going to give me my exponent squared. So hopefully you notice what happened. So the red graph is our parent function and the blue graph is what happened when we added 3 to the x inside the squared. And you notice that it actually moved my graph 3, and it moved my graph specifically 3 units to the left. So what would happen if I did a minus 3 instead of a plus 3? So y equals, again I'm going to do my parentheses, x minus 3, and we're going to do our shift 6 squared, and that's my green graph. So again, thinking of what happened from the red to the green, my green graph moved to the right 3 spaces. So when I added 3 to the x, it moved it to the left, and when I subtracted 3, it actually moved it to the right. So whenever we have a number on the inside connected to our x, we should notice that it is moving our graph either right or left. So if it's positive, it actually ends up moving it to the left, and if it's negative, it actually moves it to the right. So it's kind of a cool little trick there. So let's see what happens when we multiply something by our function. So I'm going to keep my y equals x squared, but now I want to do y equal to 5x squared. Oops, no 2. So I'm going from my red to the purple, and I hope what you noticed is that my red graph and my purple graph got a little skinnier. What it's actually doing is kind of stretching my graph up. So it actually is pulling those points up further faster. So when we multiply by 5. So what happens if we multiplied by something like a fraction? So what if we did y equals 1 divided by 5 times our x squared? So that is that black graph. Now what hopefully you noticed between the red and the black graph was that my black graph got a lot fatter. It actually pulls my points down. We call that compression. So when we multiplied by 5, and by the way this is true for any number bigger than 1, when we multiply something by a number bigger than 1, what it does is it actually stretches your graph. It pulls it up, makes it a lot skinnier. We call that stretching. When we multiply by a number less than 1, so basically a fraction smaller than 1, we actually end up doing what we call compression. It's actually pushing the points down, and it's compressing or making our graph a little bit fatter. Okay, so we now know that if we have something added or subtracted onto our x, it moves my graph either left or right. If I multiply something onto my function, or my x squared, it either stretches it out if it's greater than 1 or compresses it if it's smaller than 1. Let's see what happens if we take and put a negative in front of our x squared. So if we do y equals negative x, squared. There we go. So hopefully what you notice from this one is it actually ended up flipping the graph. It took our graph and put it upside down. So anytime we multiply by a negative, we actually say that this reflects it over our x-axis. So it takes our graph, turns it upside down. Doesn't matter what our graph looks like, that's what it ends up doing. Okay, so for the next one, we're actually going to have to change our graph a little bit. So let's actually look at, this time, y equals x to the third power. That's our snake function. So that's the one that kind of does our snake look. So let's see what happens when I do a negative inside with my x. So I'm going to do a parentheses, I'm going to do negative x, and I'm going to raise that to the third power. So look at the difference between my blue and my green. It kind of looks like it flipped it upside down, but what it actually did was it actually reflected it over the y-axis. Okay, so when the x is on the out, or the negative is on the outside of the function, it actually flips it over the x-axis. When the negative is on the inside, like this one, it actually flips it over the y-axis. So we do have two different styles of reflections. Now for the most part, the problems that you're going to be dealing with will flip it over the x-axis, but you might actually have one that does the y-axis reflections. Alright, so let's go back to our x squared function because we're most familiar with it. So I'm going to y equals x squared. Now, let's see what happens when we add a number onto our x squared. So we have y equals x squared, and then let's say we want to add 4. So notice what happened from our original graph, which this time is purple. When we added 4, our graph basically jumped up or moved up 4 spots. So it actually moved it up, or has a vertical movement of 4. So let's see what happens if we subtracted 4. So y equals x squared, and this time we're going to minus 4. So notice now what happened. It dropped it down. So it went from being at the 0 down to, or the vertex went from being here at 0, now it's down at -4, or 0, -4. So if we add or subtract a number onto our function, it is either going to move it up or down. So if it's positive, it moves it up. If it's negative, it moves it down. I hope this helped you kind of see how these graphs make these movements, but Desmos is an awesome way for you guys to kind of explore and look at what the graphs do, or what the numbers do to the graphs. It's also a great way for you to check to see if you got the right answer after you've finished your transformation. Now remember, when you do your homework in your college algebra class, it's going to do a lot of the graphing for you, but eventually you're going to have to take your midterm, and your midterm is a paper test, so make sure that you are doing a little bit of practicing on how to transform graphs by hand.